Welcome back, students. Today is lecture number 7. The topic is errors in measurement, and today we will be solving 3 or 4 numerical problems from the topic of combination of errors. We have studied about that topic in the lecture number 6. And before proceeding further, I would like to inform you that I will be creating the playlist for each and every chapter. The playlist will consist of all the lectures, all the relevant lectures pertaining to that chapter. The lectures will be marked as lecture number 1, lecture number 2, lecture number 3, lecture number 4, and so on. And after the end of the chapter, that is when we have when we have covered all the topics, then we will be uploading 2 test papers also. The test paper number 1 will be for those students who are preparing for the board examinations, and the test paper number 2 will be for those students who are preparing for the NEET examination. And finally, there will be one revision session also, which will be divided in 2 sessions. And so this is how I will be proceeding in all the chapters. And the most important thing here is that we will be focusing a lot on the conceptual physics, and we will also try to solve as many numerical problems as possible, starting from the simplest one, and we will go on further, and we will also try to solve the problems which are very tough, means up to the level of, say, IIT-JEE mains, or even up to the level of advanced also if required. So let's start with this topic, that is the combination of errors, and let's start doing the numerical problems on this topic. So today I will be taking the numerical problems which will be very easy for you, but they will be relevant for those people. It will be relevant from the point of view of the board examination. So the questions are very easy, but there will be a couple of questions which are going to be of importance for those who are preparing for the NEET examination also. So let us begin. So it's a very small question. The question says the least count of a stopwatch is 1/5 seconds. Least count of a stopwatch is 1/5 seconds. Okay. The second point is the time for 20 oscillation of a pendulum. Time for 20 oscillations of a pendulum is 25 seconds. Find the maximum percentage error. Find the maximum percentage error. This is a very small question. This is a very easy question. The least count of a stopwatch is 1/5 seconds. It means that the least count error is equal to 1/5 seconds. Or you can say the absolute error in the measurement of the 20 oscillations is equal to 1/5 seconds. Now the percentage error. The maximum percentage error will be given by delta t upon t into 100, where delta t is the absolute error, or you can say the maximum possible error in the measurement of oscillation of a pendulum, and t is the time taken for 20 oscillations. So we will put this value as 1/5 divided by 25 into 100. So which is equal to 100 by 125, that is equal to 4/5, and that is equal to 0.8%. So the maximum percentage error in this case will be equal to 0.8%. Second question is, two resistance R1 and R2. Question number 2. Two resistances R1, which is equal to 100 plus minus 3 ohm, and R2, which is equal to 150 plus minus 2 ohm, are connected in series. What is their equivalent resistance? What is their equivalent resistance? So again, it is a very easy question. Yesterday, or in the lecture number 6, we have studied that if a physical quantity Z is equal to A plus B, okay, where A and B are two different physical quantities, then delta Z, you can say the maximum possible error in Z is equal to A plus, will be equal to A plus delta A, will be equal to delta A plus delta B, where delta A and delta B are the absolute errors in the measurement of A and B respectively. Or we can say that Z plus delta Z will be equal to what? Z is equal to A plus B, so A plus B plus delta Z. Delta Z is equal to delta A plus delta B, but here we are putting it plus minus delta A plus delta B here. Now plus minus A means that now this is the error, this is the maximum possible error in the measurement of A. Now this error can exceed the value of A plus B also, and it can be less than A plus B also. That is the deviation of the error, or you can say the deviation from the true value can be on either side of this number. It can be on the higher side also, it can be on the lower side also. So that is why we have written it here as plus minus delta A plus delta B. Or you can say, for example, if A plus B is equal to 10 centimeter and delta A and plus delta B, let us say, is equal to 0.5 centimeter, let us say, or you can let's say it's 100 centimeter, then the range of the measurement of Z will be equal to how much? 100.5, and less than, that is equal to 1 will be 100.5. This is the on the higher side, and the lower side will be equal to 99.5. So the value of Z will vary from 99.5 to 100.5. If delta A plus delta B is equal to 0.5 centimeter and the A plus B is equal to 100 centimeter. Okay, so this is, so we will be following this concept in this problem. So equivalent resistance R is equal to 100 plus minus 3 ohm plus 100 plus minus 2 ohm. So 100 and 150 are the you can say the true value of the R1 and R2. So we will club both these two, that is 100 plus 150 will be written here, and then plus minus 3 plus 2 ohm. Now this is equal to 250 plus minus 5 ohms. Again, so the equivalent resistance will be equal to 250 plus minus 5 ohm, where 5 ohm is the maximum possible error in the measurement of R. Now let's move on to the third question. The length and width of a rectangle are length and width of a rectangle or L is equal to, it is a 5.7 plus minus 0.1 centimeter, and the width is equal to 3.4 plus minus centimeter. So we have to find the area with error limits. Find the area with error limits. So area will be equal to length into width. So here it will be equal to 5.7 into 3.4. So if we multiply this, then we are getting 5.7 into 3.4, which is equal to 19.38. 19.38 centimeter square. Now here we will apply the rules of counting the number of significant figures, or we will apply the rules for carrying out the arithmetic operation with the significant figures. If we apply the rule for the arithmetic operation with the significant figures, which we have studied I think in the first lecture, then as per the rule, the final answer should have that many significant digits as there are in the number which is having the least number of significant digits. But यहाँ पे क्या है, दोनों जगहों पे आप देखेंगे कि दोनों वैल्यूज़ में significant digits 2 हैं, यहाँ पे भी 2 हैं, तो हमारा आंसर होना चाहिए 2 डिजिट्स में. ये फाइनल आंसर में जो significant digits होने चाहिए वो होने चाहिए 2 डिजिट. It should have only 2 significant digits. So अब हम क्या करेंगे, इसको 19.38 है तो राउंडिंग ऑफ कर जब यहाँ पे कंसेप्ट लगाएंगे तो ये 8 हटा देंगे और ये आपको हो जाएगा 19.4 which is equal to 19.4. नाउ यहाँ पे हम इससे आगे प्रोसीड क्यों नहीं कर पाएंगे, बिकॉज अगर ये मेरा 5 से ज़्यादा होता, if let us say if this number would have been 6, in that case मैं क्या कर सकता था कि मैं 6 को हटाता and then I could have written it here as 20 centimeter square. But now because it is less than 6, then we will not do anything here. It will remain as it is. So our final area which will be taken into consideration is equal to 19.4 centimeter square. ठीक है? Now we have to find the area with error limits. So area is equal to area with error limits. So in the previous session we have studied that if a physical quantity is a multiplier of let's say 2 or more physical quantities, then their relative error, that is delta A by A, will be equal to the sum of the relative errors of the multipliers. So here the multipliers are length and width. So we can write this as delta A by A will be equal to delta L by L plus delta W by W. Okay, so delta A will be equal to delta L divided by L plus delta W divided by W into A. Okay, this is equal to, now delta L is the absolute error in the measurement of it, which is given as 0.1. L is 5.7 plus delta W is equal to 0.2 divided by 3.4 dot. So this is equal to delta A. Okay, so this delta A is the error in the measurement of area Now let us find the value of this 0.1 divided by 0.7, 0.1 divided by 0.5, divided 1 divided by 5.7, which is equal to 0.0175 plus 0.2 divided by 3.4, 0.2 divided by 3.4, so this is equal to 0.0588, 0.0588 into A is equal to 19.4. So if we add this, it is 0.0175 plus 0.058888 is equal to 0.0175 plus 0.0588. This is equal to 0.0763. 0.0763 into 19.4 into 19.4, which is equal to 1.48. 1.48. Yeah. So the area, so delta is equal to, this is equal to, delta is equal to 1.48, and now here this 1.48 can also be now written as, if we omit it as if अगर हम 8 को remove करते हैं, it is greater than 5, then it will become 1.5. So delta A will be equal to 1.5. So the area with error limit will be equal to 19.4 plus minus 1.5 centimeters. This is the answer. Okay. So here the most important thing is that first of all we have applied the concept of significant, that is applied the concept or you can say the rule of carrying out the arithmetic operation with the significant digits in the first step in finding the area, and then we know that the relative error of the measured value is equal to the sum of the relative errors of the of the multipliers. Now here the multipliers were length and width, so this is what I have written it here. So this is as per the rule of the combination of errors which we have studied in the lecture number 6, and using this formula then we have calculated the value of delta A, which is equal to 1.5. So area with the error limit will be equal to 19.4 plus minus 1.5 centimeters square. Now we will also now try to do one more question here. The question is, a physical quantity x is given by, there is a physical quantity x, this is the question number 4, which is given by, a square b square divided by c under root d. The percentage error in the measurement of A, B and C are percentage error in the measurement of A, B and C are in A, B, C and D. Percentage error in the measurement of A, B and C and D is 4, 2, 3, 1. Yeah, this is 4%, this is 3%, this is 2% and this is 1%. 4, 3, 2, 1. 4, 2, 3, 1, sorry. 4, 2 and this is 3, 1. Calculate the percentage error in the calculation of X. Find the percentage error in the calculation of X. Okay, this is the question which we have. So, in the last lecture, we have studied in under the heading of combination of errors that if any physical quantity is a multiplier of other physical quantities which are raised to some power, then in that case the relative error will be given as the sum of the relative errors of all the physical quantities which were used to calculate the final value. So, but here whenever we are getting any physical quantity which has got a power, for example here a square. So, as per the rule, now a square means that we have multiplied a 2 times. So, the error will be added, because let us say if the error in the measurement of a is delta a, again we are multiplying it by a. So, the error again will be equal to delta a. So, it will be equal to 2 delta a. So, what we do is that is 2 delta a. So, this 2 is taken it here and then we write it as delta a upon a, plus here also we have measured b twice. So, the error will be 2 times delta b divided by b. Here c is only 1 time. So, it will be only delta c by c plus d. Now, this is equal to, I will just write it down, a square b square upon c d to the power half. So, here what we will do, write it down, this power will come here, delta d by d. Simple. So, the percentage error is what? Delta x by x into 100. So, we will multiply this entire, we will multiply left hand side and right hand side by 100. So, we will get delta x by x into 100, and similarly here we will also get 2 delta a by a into 100 plus 2 delta b by b into 100 plus delta c by c into 100 plus half delta d by d into 100. So, this is the percentage error in the measurement of x. This is the percentage error in the measurement of x. Percentage error in the measurement of x, which is equal to, now delta a by a into 100 is, we are already given that the percentage error in the measurement of a is equal to 4%. So, this is equal to 4. So, 2 into 4 plus 2 into the percentage error in the measurement of b is 2. So, delta b by b into 100 is equal to 2 into 2 plus c, delta c by c into 100 is equal to 3% plus half into the percentage error in the measurement of d is equal to 1%. So, this is equal to what? 8 plus 4 plus 3 plus 1 by 2. So, the percentage error will be 8, 4, 12 plus 3, 15, 15.5%. So the percentage error in the measurement of x will be equal to 15.5%. So here what we have done is, we have applied the rule of which we have studied in a lecture number 6. That is, if any physical quantity is dependent on other physical quantity which are raised to the power or to some power, then the relative error of the final result is equal to the sum of the relative errors due to the individual physical quantity. And in this case, if the individual physical quantities are raised to some power, then that power is multiplied by the relative error. So what we have done is, here you can see here that delta x upon x is equal to 2. That is, that power is multiplied by the relative error, that b square. Then 2 is multiplied, this power is multiplied by the relative error. Okay, here there was the power is 1, so absolutely there is nothing to write here. That's delta c by c. And now here the power is half, so half delta d by d. So then we have multiplied this delta x by 100, and we have multiplied both sides by 100, and so this delta x by x into 100 is the percentage error in x, and we have got this expression. This is 4, this is 2, this is 3, and this is 1. So we have put these values in this equation, and we have got the percentage error in x is equal to 15.5%. So thank you very much for joining in this lecture, and in the next lecture I will continue solving 2 or 3 more questions. That is, in the lecture number 8 I will continue with the same topic and try to solve 3 or 4 questions, and thereafter I will be moving on to the next topic of dimensions of physical quantities. So thank you very much, and the lecture number 8 will be uploaded shortly, and hope to see you soon. Bye.